Hello everyone, welcome back to the site of resonance. Today we will going to start buoyancy and buoyant force. So basically what buoyancy means. So buoyancy is tendency of liquid to apply an upward force on an object which is immersed in it or submerged in it. Okay, so whenever you put a cork inside water and you push it with your hand, it goes down, but as soon as you remove your hand, it comes up on its own. मतलब आपने जैसे ही उस पर फोर्स लगाया अपने हाथों से तो पानी के अंदर जरूर जाएगा, लेकिन जैसे ही आप वो फोर्स को हटा देंगे तो अपने आप ऊपर आ जाता है। वो अपने आप ऊपर कैसे आता है पानी के अंदर? मींस लिक्विड ने कुछ फोर्स लगाया उसके ऊपर एंड इट इज इन अपवर्ड डायरेक्शन. That the tendency of liquid to apply an upward force, it is known as buoyancy, and the force which is applied by liquid in an upward direction when a body is immersed in it or submerged in it, that force is known as buoyant force. उस force को हम क्या बोलते हैं? buoyant force बोलते हैं. आपको बात समझ में आ गई होगी buoyancy क्या होती है. इसके और एग्जांपल्स आप ले सकते हो. If you put a mug inside bucket, what will going to happen? If you are applying a force, it will going to go down, but as soon as you will going to remove the force, the mug will automatically on its own going to come up. That tendency of liquid to apply an upward force लगाया उसने मग पे तभी मग ऊपर आया, that is known as buoyancy. उसको हम क्या बोलते हैं? buoyancy. Due to buoyancy only we can swim in liquid. हम स्विम क्यों कर पाते हैं? ड्यू टू बायंसी. अदरवाइज हमारा जो वेट है दैट इज mg विल नॉट बी बैलेंस्ड बाय एनी अदर फोर्स. इफ इट इज नॉट गोइंग टू बैलेंस वी विल गोइंग टू सिंक डाउन. तो इफ वी आर स्विमिंग इन वाटर मींस our mg is getting balanced by some upward force. That upward force is known as buoyant force, and the tendency of liquid to apply an upward force is known as buoyancy. उसको हम क्या बोलते हैं? buoyancy. buoyant force को ही हम upthrust भी बोलते हैं. So buoyant force is also known as upthrust. This force is also known as upthrust. Okay. And what is buoyant force? The upward force applied by a liquid when a body is submerged in it. Means if I am going to take a liquid like this, I have taken a liquid and in this liquid there is a body. In this liquid there is a body. So this liquid will going to apply an upward force on this body like this, and this force is known as upthrust or buoyant force. तो जब भी कोई बॉडी एक लिक्विड के अंदर इमर्स्ड रहेगी तो ये लिक्विड उसके ऊपर एक अपवर्ड डायरेक्शन में नेट फोर्स इन अपवर्ड डायरेक्शन इट विल दिस लिक्विड विल गोइंग टू अप्लाई ऑन इट. किसने लगाया ये फोर्स? लिक्विड ने. और इस फोर्स को ही हम अपथ्रस्ट बोलते हैं या फिर बाइंड फोर्स बोलते हैं. और जो टेंडेंसी है लिक्विड की ऐसा फोर्स लगाने की, उस टेंडेंसी को हम क्या बोलते हैं? बायंसी. उस टेंडेंसी को क्या बोलते हैं? बायंसी. ओके, नाउ व्हाट इज द कॉज ऑफ बायंसी? बायंसी का कॉज क्या है? लेट अस डिस्कस दैट आल्सो. सो लेट्स स्टार्ट विद द कॉज ऑफ बायंसी. See, what is the cause of buoyancy? I am taking a liquid again. And there is a body which is submerged in this liquid like this. It is not only liquids which applied buoyancy, gases also applied buoyancy. If this was a gas and a body is submerged in this gas, then the gas will also going to apply a buoyant force. And the tendency of fluid when a body is submerged in it to apply an upward force, that tendency is known as buoyancy. So केवल liquids ही buoyancy या buoyant force लगाएंगे, it is not necessary. Gases भी वो कर सकती है, but in gases the value of this buoyant force is very less. बहुत कम होती है, but लगाती जरूर है. That is the only reason that birds can fly. because the mg of bird is balanced by some upward force, and that upward force is known as buoyant force or upthrust, and the tendency of the gas or the air to apply an upward force, that is buoyancy. So if there is any body which is submerged in a fluid, and fluids are liquid and gases, we know, then that liquid or gas means that fluid apply an upward force, that is known as upthrust or buoyant force, and the tendency of the fluid to apply an upward force, that is known as buoyancy. Okay, so I have taken a liquid. In this liquid there is an object immersed in it. Okay, let us say there is a pressure at this surface, and that pressure I am taking as P1, and the force due to that pressure I am taking it as F1, and the pressure on the downward surface I am taking as P2, and the force due to that pressure I am taking as F2. The cross-sectional area of this cylinder I am taking as A, and the height of this cylinder I am taking it as cylindrical box, I am taking this height as H. Okay. See, we will going to derive that what is the formula of buoyant force, and we will also going to see that what is the cause of buoyancy over here. The main cause of buoyancy you can see is that the pressure over here, let us say the height from the depth from the free surface of this is H1. It is H1, and the depth of this surface from the free surface is, let us say, H2. Okay. We know that pressure over here will be less and pressure over here will be more. What will be pressure at this level? It will be P equals to rho g H2, isn't it? And pressure at this level will be, we have already done, it is P equals to rho g H1. Okay. So it is rho g H1, it is rho g H2. I am not considering the atmospheric pressure, otherwise it would be P naught plus rho g H1, and this would be P naught plus rho g H2. But I am not considering the atmospheric pressure. So pressure at depth H2 will be rho g H2, where rho is the density of this fluid. Rho is the density of this fluid, and let us say sigma is the density of this object. Sigma is the density of this object. So pressure at this point, that is this cross-sectional area 2, it is rho g H2, and pressure at cross-sectional area 1, it is rho g H1. As there is a pressure difference, so there will be a difference in force. There will be difference in force. We know that this pressure is more than this pressure, so F2 will be more than F1. F2 will be more than F1. Since F2 will be more than F1, there will be a net upward force acted on this object by this liquid, and that force is only known as buoyant force, and the tendency of liquid to apply that buoyant force is known as buoyancy. So what is the main cause of buoyancy? The main cause of buoyancy is the pressure difference caused due to the variation in depth. Okay. डेप्थ के वेरिएशन की वजह से जो प्रेशर डिफरेंस आता है, दैट इज द मेन कॉज ऑफ बायंसी. दैट इज द मेन कॉज ऑफ बायंसी. इफ यू आर टेकिंग एन ऑब्जेक्ट, then the pressure at this level will be different and pressure at this level will be different, due to which the force acting at this level and this level will be different. And we know that as we go down into a liquid, means as depth increases, pressure also increases. So pressure at this level is more, so force applied at this level will be more, and the force applied on this level will be less. So when you are going to subtract these both forces as they are acting in opposite direction, you will going to find that there will be a net upward force acting on this body, and that upward force is known as buoyant force or upthrust. I hope you have got that what is the cause of buoyancy. The cause of buoyancy is that there is a pressure difference due to change in depth, that pressure changes with depth. That is the main reason of buoyancy. I hope you have understood that at this level the pressure is more, and at this level the pressure is less, due to which the forces at this and this level are different. Means there will be a net force which will be acting in upward direction as the force F2 is greater than F1. So that force, that net force which will be acting in upward direction, that will be known as buoyant force, and the tendency of liquid to apply that force will be known as buoyancy. Now let us see what is F2. So F2 will be P2 into A, because area is A. I have taken a uniform cylinder, so area is uniform. P2 value is rho g H2 into A. This is my F2. This is the F2. This is equation 1. And what will be F1? I think F1 will be rho G H1 into A. This will be my equation 2. The net force applied by liquid on this object. See, the net force applied by this liquid on this object will be F2 minus F1. Because I know that F2 is greater than F1 as H2 is greater than H1 and other things are same. So this will be the net force acting on this object by liquid. It will be rho G A H2 minus H1. And I know what is H2 minus H1. I think it is capital H. The H2 minus H1. If I am subtracting H1 from this height H2, I will going to get this remaining height, which is nothing but capital H. So F2 minus F1, I am telling it as buoyant force FB, and it will be equals to rho GA capital H. Rho GA capital H. And cross-sectional area of this cylinder multiplied by this height will going to give me the volume of this submerged body. So this will going to come as rho GV. That is my buoyant force. That is my buoyant force. But see, what is rho over here? Rho is the density of fluid, not the object. Rho is the density of fluid, not the object. G is the acceleration due to gravity, and V is the volume submerged of the body. This is the volume which is submerged in the fluid. So V is the volume submerged, G is the acceleration due to gravity, and rho is the density of fluid. So it's better to write it as buoyant force equals to rho of fluid into G into volume immersed. So you have to remember the formula like this only. Don't remember it rho GV. Why? Because you will going to get confused otherwise that what is rho? Is it the density of liquid or the object, and what is V? The complete volume of object or the immersed volume. So always remember the buoyant force is equals to rho of fluid G into volume immersed. So you will never going to get confused. Rho is density of fluid. We have written rho of fluid, G is the acceleration due to gravity, and V immersed is the volume immersed of the body. You have to only take the volume which is immersed. You don't have to take the full volume of the object until and unless the object is completely immersed in the fluid. So buoyant force, I got a formula of buoyant force after deriving it. It is FB equals to rho of fluid G into volume immersed. Rho of fluid, that is density of fluid, G is the acceleration due to gravity, and volume immersed. This is the formula that you have to remember by heart, and it is very important formula. Most of the questions are framed only on this formula. Okay. I hope you have got what is the cause of buoyancy. The cause of buoyancy is the pressure difference with depth. And what is the formula of buoyancy? I got a rho of fluid into G into volume immersed. Now, see, this is the buoyant force. This force is acting on this object by this liquid. I haven't taken, this is not the net force on this object. ये net force नहीं है, mg भी लग रहा है. क्या लग रहा है? mg भी लग रहा है. ये केवल वो force है जो कि किसने लगाया है? इस fluid ने लगाया इस object पे. I have taken the resultant of the forces applied by this fluid on this object. This is not the net force acting on this object because mg is also acting downwards. We are going to see in laws of flotation that what will happen if we consider mg also. Will the object float or it will going to sink? What will happen? That we are going to see in laws of flotation. So buoyant force का formula आ गया rho of fluid into g into volume immersed. Now let's move a bit forward and see that what are the factors on which buoyant force depends? What are the factors on which this upthrust or the buoyant force depends? See, the first factor that on which buoyant force depend is the density of fluid. As you can see from formula that FB buoyant force is directly proportional to the density of fluid. So if we increase the density of fluid, the buoyant force will definitely going to increase. The buoyant force will definitely going to increase. If we decrease the density of fluid, the buoyant force will be decreased. So see, यहाँ से एक बहुत अच्छा concept आता है, that is of Dead Sea. That is of Dead Sea. What happens in Dead Sea that there is, if you are going to go and swim in Dead Sea, you will going to find that you will going to float in Dead Sea. Why? You will not never going to sink in Dead Sea. That is the only reason it is known as Dead Sea, because there is no survival of marine life. What is the problem over there? The problem is density of fluid over there is very much. Density of fluid is very high. Where? In Dead Sea. Why the density is very high? Because the salt content over there in the liquid is very much. So density of water over there is very high due to the high salt content. So what will going to happen? The buoyant force will be very much. If the buoyant force is very much, you will going to float in it. You will going to float in it. Why? Because it will going to balance your mg. It will going to balance your mg. That is the only reason the objects automatically, without swimming, they float in Dead Sea. They float in Dead Sea. So this is the concept behind it. So density of fluid is buoyant force is directly proportional to density of fluid. अगर आपने density of fluid बहुत बढ़ा दी तो buoyant force भी बढ़ता ही जाएगा, और अगर आप density of fluid कम कर रहे हैं तो buoyant force भी क्या होगा? कम. तो ऐसे क्वेश्चंस बन सकते हैं कि मैंने दो ऑब्जेक्ट रखे हैं, एक वाटर के अंदर, एक केरोसिन में, एक वाटर में, एक ऑयल में, एक वाटर में, एक मरकरी में है. कहाँ पर buoyant force ज्यादा होगा? तो आप डेंसिटी के अकॉर्डिंग बता सकते हैं कि किस लिक्विड के अंदर buoyant force ज्यादा होगा. अगर मैंने एक वाटर में रखा, एक मरकरी में रखा है, कहाँ पर object will going to float, or it's possible for object to float? Definitely it is, the more chances is in mercury, as density of mercury is more. So such types of questions can be framed from this first point, that is the first factor affecting the buoyant force. The second factor on which buoyant force depend is the volume immersed. So buoyant force depends on the volume of object immersed or submerged. This is my second point. Okay, as we can see from formula again, that buoyant force is directly proportional to the volume immersed. So if more volume of a body is immersed in liquid, there will be a greater buoyant force, and if the volume is less, then the buoyant force will be less. Why? Because we can see from here what comes in buoyant force is the volume, and this volume was the immersed volume. This volume was which was submerged in the water. So that the only reason that buoyant force is directly proportional to the volume immersed. अगर आपने immersed volume ज़्यादा है किसी ऑब्जेक्ट की और एक ऑब्जेक्ट की immersed volume कम है, तो जिसमें कम है वहाँ buoyant force भी कम होगा, और जिसमें ज़्यादा है वहाँ buoyant force भी ज़्यादा होगा. This is the second point. Moving to the third point. The third factor on which buoyant force depend, it is the acceleration due to gravity. See, we can see from formula that FB is directly proportional to G. So यहाँ से क्वेश्चन कैसे बन सकते हैं कि अगर आप एक बॉडी को जो कि पानी के अंदर सबमर्ज्ड और उस पूरे सिस्टम को आप मून पर ले गए फ्रॉम अर्थ, so what will be the changes in buoyant force? I know G will be G by 6, so buoyant force will be 1/6. Buoyant force will be 1/6. ऐसे ही ग्रेविटेशनल के साथ इसको कंबाइन कर सकते हैं कि अगर एक बॉडी को आप h हाइट पर ले गए जो कि पानी के अंदर सबमर्ज्ड है, उस पूरे सिस्टम को आप h हाइट पर ले गए फ्रॉम अर्थ सरफेस और d डेप्थ पे ले गए फ्रॉम अर्थ सरफेस, व्हाट विल द चेंजेस इन buoyant force? Again, there can be other questions from NLM, like if there is a system in which there is a bucket and there is an object in it. Now I have put that system in a lift. and I am accelerating that lift with some acceleration in upward direction, what will be the change in buoyant force? तो जैसे जैसे g चेंज होगा, इन सारे क्वेश्चंस में जो मैंने अभी आपको बताया क्या हो रहा है, g चेंज हो रहा है, और हमें डिस्कस कर चुके हैं कहाँ पर, NLM में भी डिस्कस कर चुके हैं और ग्रेविटेशन में भी डिस्कस कर चुके हैं कि g कैसे वेरी करता है। तो जहां जहां g वेरी करेगा वहां बाइंड फोर्स भी वेरी कर जाएगा। g ज्यादा हो रहा है तो बाइंड फोर्स भी ज्यादा हो जाएगा, g कम हो रहा है तो बाइंड फोर्स भी कम हो जाएगा। तो उसके अकॉर्डिंग हम हर क्वेश्चंस को, हर टाइप के क्वेश्चन को कर सकते हैं, which will be on this third point, which will be depending on this third point, that FB is directly proportional to acceleration due to gravity. Now moving to the fourth and the last point, that buoyant force also depends on temperature. And here it is the only first and the only case in which it is inversely proportional to something, and it is inversely proportional to temperature. Buoyant force is inversely proportional to temperature, because as temperature increases, what happens, the density decreases. So density of fluid will going to decrease. As density will going to decrease, the buoyant force will going to decrease. That is the reason why buoyant force is inversely proportional to temperature. Buoyant force is inversely proportional to temperature. So when you will going to increase the temperature, the buoyant force will going to decrease. And if you are decreasing the temperature, the buoyant force will going to increase. Okay. So we have seen what buoyancy is. Buoyancy is the tendency of a fluid to apply an upward force on a body which is submerged in that fluid. That upward force which is acted on a body submerged in a fluid by the fluid, that force is known as buoyant force or upthrust. हम उसको upthrust भी बोलते हैं. What is the cause of buoyancy? The cause of buoyancy is the pressure difference with depth. There is a pressure difference created with depth, and that pressure difference gives the birth to buoyancy. And what is the formula of buoyancy? Formula of buoyancy is rho of liquid into g into volume immersed, means density of fluid multiplied by g into volume immersed. After seeing this formula, we have also seen the factors on which buoyant force depends. Buoyant force depends on density of fluid. As you are going to increase the density, buoyant force will going to decrease. In Dead Sea, the density of fluid is very high. That is why the buoyant force is very high. That is why objects float in Dead Sea. Volume of object submerged. Here the questions which can be framed from the first point is that if there are two objects, one in kerosene, one in oil, or one in kerosene, one in water, and one in mercury, on which object there will be more buoyant force, you can easily do. The buoyant force will be more in which the density of fluid is more. Volume of object submerged. See, buoyant force is directly proportional to volume of object immersed or submerged. Means if there is an object which is completely immersed, and if some part of an object is immersed, then you can see in which buoyant force will be more. The buoyant force will be more in the object which is completely submerged. So the volume of immersed, it is a very important point that buoyant force depends on it directly. Acceleration due to gravity is the third point. So buoyant force also depends on acceleration due to gravity. If you are going to increase the acceleration due to gravity, the buoyant force will going to increase, and if you are going to decrease the acceleration due to gravity, buoyant force will going to decrease. So there are many questions which can be framed on third point also, combining with gravitational concepts or by the NLM concepts. It also depends on temperature. That buoyant force is inversely proportional to temperature. If you are going to increase the temperature, the buoyant force will going to decrease, or if you are going to decrease the temperature, the buoyant force will going to increase. See, now I will going to tell you one more thing, and then we will going to end up this topic, and we will going to start a new topic in our next lecture. The concept is that if there is an object which is inside some liquid like this, or inside some fluid, so there will be loss of weight of this object. Why? See, when this object is in air only, so the weight of this object is equals to mg. Weight of this object is equals to mg, isn't it? We know, we have already studied that weight equals to mg when this object is in air. But as soon as this object goes down into a liquid, what will going to happen? See, What are the forces which are acting on this object? I think one force is W equals to mg, or you can say not W over here, it is only mg, that is the earth pulling down this object towards its center, that is the force of gravity. So mg is acting downward, and I know a buoyant force is acting upward. A buoyant force is acting in upward direction, that is Fb. So the net force which is acting on this body, see this weight equals to mg is coming from the spring balance that I have tied to this box. Okay, so this is spring balance is showing W equals to mg. Now if I will going to have that same type of spring balance over here on this object, what this spring balance will going to read? This object is at static position in this fluid. I think there will be, see over here tension equals to mg, and tension is nothing, it is the weight which will be calculated by this spring balance. Over here tension will be, tension minus Fb will be equals to mg, as this body is at rest or it is in static position. So net force in upward direction, it is tension and buoyant force. So tension plus buoyant force, tension plus buoyant force will be equals to the net downward force, which is mg. So net force is balanced on this body. So what tension will going to come? I think it will going to come mg minus Fb, and this tension is nothing but it is will be the weight, that will be mg minus Fb. मैं आपको आपस बताता हूं, जब ये बॉडी एयर में थी मैंने इसको एक स्प्रिंग बैलेंस से लटकाया और क्या देखा मैंने कि स्प्रिंग बैलेंस की टेंशन और mg बराबर होंगे, क्योंकि बॉडी रेस्ट पे रहेगी तो टेंशन इक्वल्स टू mg, और टेंशन कुछ नहीं होता, टेंशन जो आएगी इस स्प्रिंग बैलेंस में वही ये शो करेगा एज अ वेट, तो वेट इक्वल्स टू mg आ गया। जो स्प्रिंग बैलेंस में टेंशन आती है, हम स्प्रिंग बैलेंस में पढ़ चुके हैं, वो टेंशन ही किसके बराबर होती है? वेट के बराबर, जो ये स्प्रिंग बैलेंस शो करता है। स्प्रिंग बैलेंस किसकी रीडिंग बताता है? हमें टेंशन की रीडिंग बताता है। तो टेंशन क्या आएगी यहाँ पर? वेट के बराबर आ जाएगी, जो कि mg आ गई। जब मैंने इस स्प्रिंग बैलेंस को इस बॉडी से अटैच करा और इस बॉडी को पानी या किसी भी लिक्विड के अंदर या किसी भी फ्लूइड के अंदर डाला, क्या हुआ? mg नीचे लग रहा था, बाइंड फोर्स ऊपर लग रही थी और टेंशन स्प्रिंग बैलेंस के ऊपर लग रही थी। अब ये बॉडी रेस्ट पे थी, इसके अंदर गई और रुक गई, कुछ स्प्रिंग बैलेंस में स्प्रिंग स्ट्रेच हुई होगी और फिर ये बॉडी रुक गई होगी। तो टेंशन प्लस Fb, टेंशन और Fb कहाँ लग रही है? ऊपर डायरेक्शन में। टेंशन प्लस Fb किसके बराबर होगा? mg के बराबर होगा। तो यहाँ पे टेंशन की वैल्यू आ गई मेरे पास mg माइनस Fb। बच्चों अगर टेंशन की वैल्यू mg माइनस Fb आई है तो टेंशन कुछ नहीं होता, टेंशन ही तो ये स्प्रिंग बैलेंस रीड करके हमें रीडिंग दिखाता है, तो ये वेट होगा। ये टेंशन ही क्या होगा? वेट होगा, क्योंकि स्प्रिंग बैलेंस क्या रीड करता है? वेट रीड करता है। कैसे? बाय मेजरिंग द टेंशन, बाय मेजरिंग द टेंशन। इस टेंशन की वजह से यहाँ वेट को शो करेगा, तो वेट इक्वल्स टू mg माइनस Fb। अगर आप गौर से देखें तो यहाँ पर वेट mg आया और यहाँ पर वेट mg माइनस Fb आया है, मींस वेट के अंदर कुछ लॉस हुआ है। कितने का लॉस हुआ है? Fb जितना। कितने का लॉस हुआ है? Fb। वहां वेट mg था, यहाँ पर वेट mg माइनस Fb हो गया, मतलब कुछ वेट में लॉस आया है, और वो लॉस इन वेट किसके बराबर है? लॉस इन वेट, दैट लॉस इन वेट इज इक्वल्स टू बाइंड फोर्स। तो बाइंड फोर्स जितना ही बॉडी के अंदर लॉस इन वेट भी होता है, जितना बाइंड फोर्स लगता है उतना ही लॉस इन वेट होता है। या आपने अपने घर पर कभी करा भी होगा, इफ यू आर टेकिंग अ मग and you are putting it into the bucket full of water, you will going to find that that mug will be appearing lighter in the liquid, and as soon as you will going to pull that mug upward outside that liquid, you will going to feel it heavy. You will going to feel it heavy. Why? Because जब आप उसको उठा रहे हो तो आप उसके mg को बैलेंस कर रहे हो, तो आपको जो वेट उसका फील हो रहा है that is equal to mg, but when it is in liquid आपको सपोर्ट कर रहा है बाइंड फोर्स। आपके फोर्स को कौन सपोर्ट कर रहा है? बाइंड फोर्स। तो आपको हल्का लगेगा, क्योंकि अब आपको mg जितना फोर्स नहीं लगाना पड़ेगा। कुछ फोर्स mg का किसने बैलेंस कर रखा है? बाइंड फोर्स ने बैलेंस कर रखा है, और कुछ जो बाकी है वो आप बैलेंस कर रहे हो। तो आपका नेट फोर्स रिड्यूस हो जाएगा, तो आपको वो क्या लगेगा? हल्का लगेगा। तो लॉस इन वेट किसके बराबर है? बाइंड फोर्स। किसने आपकी मदद करी? बाइंड फोर्स ने। जितनी मदद करी उतना ही तो कम वेट लगेगा, दैट इज लॉस इन वेट, दैट इज लॉस इन वेट। आई होप यू हैव अंडरस्टूड व्हाट इज लॉस इन वेट। लॉस इन वेट इज इक्वल टू बाइंड फोर्स। वी हैव डिराइव्ड आल्सो that if a body is attached to a spring balance in air, that weight will going to come mg, because I'm neglecting the bind force of air, it is very least. Why? Because the density of air is very less. So when I have immersed this object in a fluid and again attached a spring balance, what I have find the tension is in upward direction, buoyant force is in upward direction. So tension plus buoyant force will be equals to the net downward force, that is mg, as body is static. So tensions come out to be mg minus fb. Now what is fb? It is subtracted from mg, means the real weight was mg. Now there is something which is subtracted from mg, means the real weight has gone down. The real weight has gone down by how much? By fb. So loss in weight is nothing but this fb, that is the buoyant force. So बॉडी के अंदर लॉस इन वेट होता है जब भी बॉडी किस में जाती है, किसी भी फ्लूइड के अंदर जाती है, और वो लॉस इन वेट किसके बराबर आता है? जितना buoyant फोर्स लगा. प्रैक्टिकली फील भी आपको मैंने दिला दिया. यू कैन डू इट एट योर होम. टेक अ मग, put it in a bucket full of water. You will going to find it lighter. As soon as you will going to take that mug outside the bucket, you will going to find that mug a much or a bit heavier. Okay, so thank you for today. We will going to start Archimedes principle in our next lecture. Thank you very much.